We are now going to review factoring. There are two types of factoring. There's factoring using the greatest common factor, or there's the factoring using the box, which splits things into two binomials. Okay, we'll work on the easiest one first. So, number one, is there a greatest common factor between 2x and 6? 2. So I pull out a 2, and what am I left with? X plus 3. Okay, what about the next one? 2x, and what's left? 3x minus 2. Anybody have trouble with that? Okay. 9x plus 16. This is prime. It doesn't factor. Anything that doesn't factor is referred to as prime. Okay. Number 4 is a little bit different. Does it have a greatest common factor? No. So we're going to check to see if it can be factored either using the box or just factoring using binomials. So in the box, I put in x squared in the first one and negative 15 in the last one, and then what? Hang on. Multiply them together. You have to multiply the first and the last together. Now, sometimes you don't need to, but sometimes you have to. So I multiply x squared and negative 15, I get negative 15x squared, and then I factor it. Are there factors of negative 15x squared that add to be negative 2? Negative 5x and 3x. Those add up to be negative 2x. So negative 5x and 3x multiplied together make negative 15x squared. But added together, they make negative 2x. So those two factors go in the remaining two boxes. Does it matter where you put them? No. So 3x, negative 5x. And now we look at the top row. What does the top row share? X. That's the only time you look for sharing. From then on, you just divide. Or, I guess, look at the multiplication. X squared divided by x is x. Or you could look at it the other way. What times x is x squared? So for this spot, x times what is 3x? So this is plus 3. And then for this spot, x times what is negative 5x? Negative 5. And those are the factors. X plus 3 and x minus 5. That's factoring using the box. We created two binomials. Hopefully this is review. Is anybody lost? Okay, hang on. We'll keep going through it. And if you need more help in the end, then we'll help you out. All right, number 5. Is there a greatest common factor? No, so we use the box. X squared and 6, multiply those together, 6x squared. Are there factors of 6x squared that add to be negative 5x? Is it 2 and 3 or is it 1 and 5?
2 and 3. You have to add the negative 3 and negative 3.
But what about 1 and negative 6? Then the 6 would be negative, right? So it's got to be negative 2 and negative 3. So negative 2x and negative 3x. So negative 2x and negative 3x. So this would be x. X times what is x squared? X. X times what is negative 2x? Negative 2. And x times what is negative 3x? Negative 3. So x minus 2 and x minus 3. If you take x minus 2 and x minus 3 and multiply them together, it will simplify to be x squared minus 5x plus 6. Yes? We'll get there, yes. That's on the next section. So yes, that will come, but not yet. All right. Number 6. We build the box. X squared and 49. Multiply those together, x squared, or 49x squared. Are there factors of 49 that add to be 14? 7 and 7. So 7x and 7x. Now, do I really need to multiply the x squared and the 49 in order to solve that? Not in this case, but in a little bit you're going to need to, or it won't work. So this is x, and that will be plus 7 and plus 7. So either x plus 7 listed twice, or you can write it as a square. And it doesn't matter. It's the same answer either way. I'm just lazy. All right. Number 7. So I draw the box. X squared and negative 56. Are there factors of negative 56 that add to be 15? 7 and 8 don't work. Right? This one is prime. It looks like it needs to work, or it wants to work. But the 56 is negative, which means that the signs need to be different. So it's either negative 7 and positive 8, or positive 7 and negative 8, and neither of them give you 15. So that one is prime. Okay, number 8. So I draw the box. X squared and 72. Are there factors of 72 that add to be 18, negative 18? Negative 6x and negative 12x. So x minus 6. So my factors are x minus 6 and x minus 12. They're both minus. Yeah, it's negative 18. They're either both positive or both negative, and in this case, they're both negative. All right. Okay, number 9. Good. We got to pull out a 2 to begin with. So in my final answer, I'll have 2 times whatever else I get. Okay? So it's 2 times x squared plus 6x minus 7. Now I just put the quadratic in the box, and I ignore the 2 for a little bit. So x squared and negative 7. So negative 1 and 7. So I get a negative x and a 7x. So that will be x minus 1 on the top and x plus 7 on the side. Like that. Does that make sense? Okay, is everybody doing okay? Hopefully this is all review. Nate, you all right? Okay. Number 10. Can I pull out a 3? Well, does 3 go into 84? 8 plus 4 is 12, and 3 goes into 12, so it's got to go into 84. So it's going to be 28 times? 28 times. So 3 times x squared minus 3x minus 28. Okay. Are you good enough to do this without the box? Are there factors of 28 that create 3, negative 3? 7, negative 7, and positive 4. If you're good enough at doing that, jump straight to that step and skip the box. So it's going to be 3 times x minus 7 and x plus 4. Now, if you need to use the box, that's okay. But as you do this more and more, you'll start to see, wait a minute, I don't need the box for simple problems like that. Except on the next one, we run into a problem. I cannot take out a 3. If you cannot take out a 3, what does that mean? you have to multiply the first and the last. And once you get to the find the root section, at least one of your answers will be a fraction. If that leading coefficient does not divide out, then one of your rational roots is a fraction. If they exist. They might not exist. So, if this does not go away, you need the box. Now, when I was in school, I learned how to do this without the box, and it was way harder than the way that I'm teaching you guys. So, just be grateful you don't live in the dark ages. So 3x squared and negative 2, you need to multiply those together. Negative 6x squared. Now, are there factors of negative 6 that add to be negative 5? Negative 6 and 1. So we get negative 6x on one side and 1x on the other. And it gets a little bit more tricky here. What does the top row share? 3x. 3x times what is 3x squared? X. 3x times what is negative 6x? Negative 2. X times what is x? 1. And then you can always double check, is 1 times negative 2 negative 2? Yeah. So my factors are x minus 2 and 3x plus 1. Yeah, when we get to the roots part, then we'll end up dividing by 3. But this top half just says factor. Okay? So the last one, can I pull anything out? An x. I can pull out an x, 4x squared plus 4x minus 3. And now I draw the box, 4x squared and negative 3. Do I need to multiply those together? Yes. Whenever there's a leading coefficient, you have to multiply the first and last. So that's negative 12x squared. Are there factors of negative 12 that add to be 4? 6 and negative 2. So we put 6x on one side and negative 2x on the other. And again, it doesn't matter where you put them. It will just change the order of your factors. What does the top row share? 2x, so what goes on top? 2x, and next to that, plus 3, and down here, negative 1. So what are my factors? Hang on, don't forget. X, and then 2x minus 1, and 2x plus 3. Okay, now, the bottom is exactly like the top with one additional step. On the bottom it says factor and then find the roots. What's the difference between factoring and finding the roots? You have to solve, and for every x, there is a root. So essentially what you would do is go through and write equals 0 every time there's an x. So this root would be 0. So for this one, 2x minus 1 equals 0. We would add 1. So 2x equals 1. And then divide by 2. X is 1/2. And this one would be not a third, not 2/3, negative 3 over 2. Because you would subtract the 3 and then divide the 2. Okay, look at number 13. So, can we pull out a greatest common factor? A 4. So I pull out a 4 and I'm left with x plus 4. But all I want are the roots. What does that 4 tell me about the roots? Nothing. I can get rid of it. 4 is a factor. If you're dealing in factors, you need to keep it. If all you care about is the root, then the 4 doesn't mean anything. And it will change the shape of the graph. So what's the difference between the graph of 4x plus 16 and x plus 4? 4x plus 16 is way steeper. X plus 4 is much more shallow. What do they have in common? The place that they hit the x-axis. So the original graph looks like this. And the other one looks like this, but they share the root. So dividing a polynomial by a constant will change the graph, but it will never change the roots. If all you care about are the roots, divide it and throw it away. You don't need it anymore. Okay? So what is the root? So we set this equal to 0 and we subtract the 4. Okay? Can we divide anything out of the next one? 6x. And then x minus 2. Do I need the 6? No. Do I need the x? Yes. The root is 0. And the other root would be 2. Okay, number 15. We can't factor it, but does it have roots? Yes. So we set it equal to 0. We subtract 16. 9x equals negative 16. Divide by 9. The root is negative 16 ninths. All right. Number 16. Can we pull anything out? No. Are there factors of negative 16 that add to be 6? Negative 6? Negative 8 and 2. So x minus 8 and x plus 2. What are the roots? So x equals 8 and negative 2. Okay. Number 17. Are there factors of 6 that add to be negative 7? Negative 6 and negative 1. So the roots would be 6 and 1. Okay, what about the next one? Six and 6, so the roots are x equals negative 6. Should I list it twice? No. How does a parabola hit the x-axis once? It bounces off. Anytime you have a double root, then that quadratic bounces off the axis. So yeah, it's either the maximum or the minimum. So if I'm out here at 6, right there you can see that that parabola has 2 roots, 2 roots, 2 roots, 2 roots, and those 2 roots become 1. And that's actually called a perfect square trinomial. It's x plus 6 squared. Well, in this case, I put it on the wrong side, but you get what I mean. Just flip it all around in your head. Okay. So, number 19. Are there factors of negative 56 that add to be 8? It's kind of harder. Let's go through 1 and 56, 2 and 28. Does 3 go into 56? 5 and 6 make 11, so no. So 4 and 14, nope. 5 doesn't work. 6, does 6 go into 56? No. 7 and 8. So this one is prime, but wait a minute. We're not trying to factor it. It says find the roots. Does this have roots? Yes. What are they? They're either imaginary or irrational. In fact, this one does touch. I can guarantee this one touches because the y-intercept is negative 56. So it touches down here at negative 56, and it's positive. So it either looks something like that. Unknown. We would have to use the quadratic formula to find it, and it would have a square root in it somewhere. So, yeah, we'll get to that again. Or you could complete the square, but we're not going to do that today. Okay, number 20. X squared minus 2x plus 72. So, are there factors of 72 that add to be negative 2? They're both negative, right? And they have to add to be 2. Think about that for a second. It's not going to work. So that one is also unknown. And That one is imaginary. That one hits the y-axis so high up that when it comes down, it misses. Right. The -2 tells us how far from the y-axis the minimum deviates. So the bigger the middle number, the further from the y-axis the minimum is. So the parabolas all start right here. And yeah, the middle number dictates how far it moves from there. Because if there is no middle number, then it's centered on that y-axis. The last number moves it up and down. Well, it's kind of complicated the last two interact together. So the middle one, -2x, is not always the same. Because you could changing the last one will also change the minimum. The last two numbers work together. So, all right, 21. I pull out a 2. Do I need it? So divide by 2, x squared minus 4x minus 21. Are there factors of 21 that add to be 4? So x minus 7 and x plus 3. So my roots are 7 and -3. Okay? And then 22, you're going to divide by 3. I'm going to let you work on that one. Let's go to the end. Can I pull out anything on the last one? An x. So if I pull out an x, I'm left with 6x squared minus x minus 2. Is that x needed? Yes. Why? One of the roots is 0. So x equals 0. Okay? Now, we put this in the box. 6x squared and -2. We times those together. -12x squared. Are there factors of -12 that add to be -1? -4 and 3. What does the top row share? 2x, which makes this 3x minus 2. And this is 1. So I have 3x minus 2 equals 0. And 2x plus 1 equals 0. So add 2 and divide by 3. So 2/3 is one of them. And then subtract 1 and divide by 2. -1/2. Okay? All right. Those are your assignments. Get to work.